All right, hello. If you have a Minisforum N5 Pro or any system with the JMicron JMB585 SATA controller, your data may be silently corrupting. Here's the fix. It came from a Minisforum Discord community, and I'll explain why it works and what the real fix is afterwards, quote unquote, on Fedora or RHEL. Um, First off, let's switch over here to this here. All right. Workaround. Go ahead and enter this. Reboot. No patch kernel needed. Works on any stock kernel. After reboot, verify that it took. Uh, Type in that. You should see the page table there. And if you're on any of these distros, go ahead and do this. All commands are in the description and the GitHub repo link below. If you're on BTRFS or ZFS, run a scrub after applying to check for existing damage. When you're done, go ahead and do your scrub. Uh, your drive will be somewhere else or named something else. If you have any of this, you can't detect any corruption. Consider migrating. Not sure if you have the controller. Type that in. If you do, voila, you're affected. Let's come back. Um, Oh yes, I should mention some people in the Discord applied this workaround and still had issues. The kernel patch targets the problem differently at the controller level instead of the IOMMU. So it may help where page table v2 didn't, but instructions and the patch are in the GitHub repo. Now let me show you what's actually going on. The JMB585 SATA controller tells the Linux kernel it can handle 64-bit memory addresses. It sends a hardware flag called S64A, supports 64-bit addressing. Let's check out the text here. Yep. And see that 64-bit flag? The kernel reads it, trusts it, and starts sending data to addresses anywhere in memory. The problem, the JMB585 can't actually do it. When the kernel hands it addresses above the 4 GB boundary, the controller sends the data to the wrong place. No error, no warning, just corrupted data. When I first checked my BTRFS device stats, I had over 56,000 corruption errors on one drive and 55,000 on the other. Smart said the drives were healthy. D-message had nothing. This is the same bug as Media ASM 1062 had. Also lied about the 64-bit DMA, already fixed in the kernel years ago. So why does the regular N5 work fine with the same controller? It's the processor. The N5 has Zen 4, the N5 Pro has Zen 5. The Zen 5 IOMMU uses a five level page tables, a 57-bit address space, so it hands out much wider addresses. The JMB585 was already getting away with this lie on the N5 because the addresses stayed in range. So the N5 Pro exposed it. The page table v2 workaround constrains the IOMMU to 47-bit addresses, so the controller never sees an address it can't handle. It works, but it's a band-aid. You're limiting your entire platform because of one controller. The proper fix, well, quote unquote again, we'll see how that goes over time, tells the driver not to trust the controller's 64-bit DMA claim. Let me show you guys the patch. There's that at patch. And just looking through, this is what changes. There's a brief description of what we have. We're adding the JMB585 to the same list as the ASM 1062 controllers that claim 64-bit but can't do it. The kernel already has this mechanism. It just didn't know about this controller yet. On my patched kernel, let's go. Boom. Controller can't do 64-bit DMA, forcing 32-bit. The kernel knows the truth. After the patch, I reset my corruption counters, ran a full stress test, 8 jobs, random reads and writes with SHA 256 verification, and scrubbed over 10 terabytes. I did plenty of scrubs and did some stress testing. And basically, the system's been soaking for a while now, at least over a week, easily. Let's go stats. Did I pass it? No, it's right there. There we go. 0. Every counter, 0. This patch has been submitted to the Linux kernel mailing list. If accepted, it ships in every Linux distribution automatically. No workarounds needed. Finally, I want to be transparent about how this was done. I saw people in the Minisforum Discord losing data and getting nowhere with support. Users like dlitznet, sorry if I pronounced that wrong, did critical early analysis on the IOMMU behavior. I built on that work and directed the investigation. Claude, Anthropic's AI, wrote the patch and did the deep kernel source analysis. I directed the research, tested and verified everything on my own hardware, and I've read through every line of that patch and understand what it does. A friend of mine gave me the project framework that kept it all organized. This was a team effort, and I think that's worth being honest about. Everything is in the GitHub repo, full analysis, the patch per OS instructions, all the evidence, links in the description. If you know someone with an N5 Pro, send them this video. And thank you guys for watching, and have a great day, guys.